Alright, this is Dr. Carroll, and today's video is about constructors and destructors. So a constructor is called when an object is created. So when is an object created? Well, you have the instance where it's an automatic variable, and it's created then. The other time is when it's a dynamically allocated, for example with new. In each one of those instances, a constructor will be called. It's an opportunity to initialize member data. It has no return type. It can have parameters. And you can have multiple constructors. And it's invoked automatically. So what is the syntax for a constructor? We have a data type. And then here I'm showing with the scope resolution operator to illustrate that the data type is the same as the method name. And then we could have that with no parameters, or we could have a similar construct with a parameter list here. And then what is commonly done with initialization list with constructors is provide an initialization list. And this can be illustrated well with an example. Here we have a simple rectangular class, and we have three constructors. One that takes no parameters, constructor 1 here as the label indicates. One that takes a height and a width, and then another one that we'll talk about in just a minute. Here's the .cpp file. These are available in the private directory. Here we have the implementation. Notice the class name, it's repeated again, no parameters, and this is the default constructor. So we initialize the data members to something intelligent. Here notice we pass in a height and a width. And here is the initialization list. Initialization list has the variable names, the data member names, followed by parentheses or curly brackets starting in C++11, and then the argument of which to assign them. Initialization lists can be required in some instances. I would encourage you to compile that and execute it and watch it and see the ordering and how things are printed out. Okay, let's talk about default constructor. Default constructor has no parameters. It's generated automatically by the compiler if the user didn't define it. Okay? And that can be very appropriate. It can be very helpful. It just depends on the circumstances. In that previous case, we defined our own constructor that took no arguments, and so there was not a default constructor generated by the compiler. For initialization lists, as illustrated by that simple example, if class A has a member that is an object of another class, we'll say class B, and the other class B's constructor requires arguments, it has no other option, it requires arguments, then we must pass the arguments to class B's constructor with the constructor initialization list. This will surface again when we talk about inheritance. Okay? Just by default, use initialization lists. Let's talk about copy constructors. Copy constructors makes a copy of an object of the type that it belongs to the class. When are they invoked? When the object is passed by value, when it is returned by value, when the object is defined and initialized. For example, you could have a list object and you're declaring it and you're passing in another list, then a copy constructor would be called. They can be expensive, so you could avoid them by using references when possible, but there are certain times that you just need to use them. If you omit providing a copy constructor, one will be generated for you, and it'll by default make a shallow copy. A shallow copy makes a copy of all the values of the data members from the one object to the new object. If this is sufficient, then just let the compiler generate a copy constructor if possible. Okay. Copy constructors have one argument and only one, and that's a reference to an object. So the syntax for a copy constructor is we have our data type, and then we want to make it const so that we know that it's not being changed, and we want a reference, as mentioned, to that data type, and then we might name it right hand side. For example, we might have a list class and we're trying to make a copy of it, so then we'll provide the argument to that is a reference to a list, and we might name it a list, for example, and that might be sufficient. In the private section there's more examples of these. Now let's move on to destructors. Destructors are set up so that they can release resources. By resources, allocated memory, open files, handles, etc. Anything that resources that it got. So allocated memory is one of the most common ones. And so if a data member is a pointer, you probably need a destructor. It has no return type, it has no parameters, it's invoked automatically, and the compiler will generate a default one if one is not defined. If one is needed, then you need to declare one. The syntax for a destructor is you have the data type, and then it's followed by colon, a tilde. Tilde is the key here to distinguish from the constructor. That's all for today.